Ah, another draft physics video presentation, such mostly. Anyway, so Daftloday made another video concerning the orthodoxy versus, and I assume it'll have something to do with this idea of energy and whatnot. So I thought I would just go over some of it really quick. A couple of talking points. Sorry, I couldn't get the text any bigger. I have to use a different, I guess, Linux doesn't make like a rich text format, like a really simple, you know, editing. It's either complicated editing or too simple, but nothing in between. But anyway, um, so for force versus matter. So this is the subject that I think is, it's the huge elephant in the room kind of thing. Whatever however you want to describe that, gorilla, elephant, monster. Um, the idea that there's no accounting for the energy that is used in the process of gravity or used in the process of electromagnetism or magnetism by itself even. That obviously the magnet is emanating, a power, that compels other things to move and do things, and that there's no accounting for where that energy came from, no place, no origin. And because they don't really understand that it's coming from the field, the gravity, same field that creates gravity is creating magnetism. This is, the same filtered pressure of these little bits. They're constantly bombarding everything in the universe. But they don't have any such source. So they sort of have to make it come from the thing that produces the force. So in the example of gravity, their theory is something like space is contracted. It's like eliminated or destroyed as you go close to the sun. So space is contracted a lot. Close to the sun, it consumes it, destroys it. So in between particles, the space disappears, and that's what moves them together. As they were here, the space goes away, so they go here. And the further away you get, somehow this space contraction thing gets less and less often. It disperses. And so even though it looks exactly like, that theory creates exactly the same pattern as having an external pressure pushing in, exactly the same, having a real force, little bits, pushing in from the outside, would do exactly what this contraction of space from the inside would do. And that would be a nice mechanical model versus a silly how does the space disappear thing, and how does the space disappearing thing spread by the inverse square law. There was a Susskind video that Daftloday played where in one part of the video he was explaining how Newton devised the inverse square law. And I thought it was kind of funny because he went to Kepler and he started talking about Kepler's laws, and like somehow Newton got it from Kepler. And I thought that was just I thought it was funny. It's just wrong funny. Just because Newton did so many light experiments, I'm sure Newton took his version of a flashlight, a candle light, and changed the distance and realized as you change the distance the light gets 4 times weaker, had double the distance. And I'm sure he could do this simple hand trick. I'm sure he did that. He said, look how big my hand is. 4 times smaller. 4 times bigger. 4 times smaller. I'm sure he did that. So I don't think he needed Kepler to figure out the inverse square law is common to everything related to these force elements. It's the way the forces, all of them behave until you turn them into laser beams or something. That's how they behave. Alright, anyway, so I'll read some of what I wrote here just as talking points. So force bits act on matter bits. So this is just the simple bit. Is that gravity is a nuclear force and magnetism is a nuclear force. It's the little bits that are doing all the action, and the little bits interact with the little matter bits, and the little matter bits interact with the force bits, but the force bits don't interact with the force bits, and the matter bits don't interact with the matter bits. So in a way, when my 2 fingers bang into each other, the matter isn't hitting each other. The electrons don't hit each other. They get close and they compress a bunch of force between them. And that force gets very high pressure because it's a little thing bouncing back and forth. So the closer I bring it, the more it bounces back and forth, the more pressure it creates going out. And so you can never create maximum pressure between two pieces of matter, because when you get even close to that, the pressure on the inside is so much greater than the pressure on the outside that it won't go any closer. It'll force it to rebound. And that's the way it works. So matter doesn't really interact with matter either. They're conduits to each other. Force doesn't mean anything without the matter bits, and the matter bits don't mean anything without the force bits. So anyway, gravity is a nuclear force. So I've already said that. All forces are nuclear. So it's just kind of redundant, but just so I have to understand that all the interactions are about moving electrons, protons, and neutrons. They're the things that move. When you move, and my finger moves, it's the protons, electrons, and neutrons in here that are moving. They're the actual things getting pushed by force. The force doesn't hit here. The force goes into here, and this is because this is a medium. It waves through the whole thing. The whole thing feels the force. Every little tiny bit inside of here feels this force. Alright, electrons, protons, and neutrons have to be moved by force. So again, they don't just magically move. Space doesn't disappear and they get closer together. I mean, do you really think that makes sense? That somehow this magical space contraction thing, that there's any logical way you could contract this space in some way where you wouldn't screw everything up? As a force emanating, like more contraction here, less contraction here, less contraction here, less, it would end up, it'd break everything. Anyway, the inverse square law is the law of dispersion. So the simple truth is, it just has to do with the fact that this small circle and this big circle require, if I take this mass and I spread it out this big, I have to break it up into little pieces and spread it out. And it's just like that with gravity, right? I mean, I could break every piece of me apart and make it into separate little atoms, separate them, disperse me into separate atoms, and all my atoms will move just like that with the whole body, because it's the little bits inside the atoms that are actually doing the moving. They're getting moved by the force. The force travels by means of the pressure between things. So once my atoms are connected to each other magnetically, they just automatically will transmit any force that goes in one. It moves the one atom, it's going to move the other atom, and it's going to move the other atom, that's going to move the other atom. They're all bound by a tension. Probably not. Yeah, so it's the law of dispersion. So it's just this idea that if you take something from here and has to spread over this area, that it's going to be diluted. It'll be 10 bits per, how do they say it, 10 parts per million here, and here it's going to be 10 parts per billion. Anyway, their theory requires collapse in space to move out from a gravitational source. So a source of gravity is basically consuming empty space between things, just eating the space somehow. And that has to spread by the inverse square law. It has to disperse into the universe like a substance. So this, what Ken Wheeler used was this counter space has to spread. As alternative to a mechanism where you have force bits, little bits of stuff pushing from the outside, a much more rational explanation. More collapse close, more collapsed space close than far away. Just like I said, it just makes so much more sense to say, that's a pressure equation. Let's see. Especially when you think about what happens to conversion of the pressure when you, like us being on Earth, the gravity pushes us, and then we push the chemistry below us. We push the atoms, essentially. We push the electrons tighter together below us in the atoms, and we compress the atoms. The atoms get more and more, they get forced to be closer and closer together and have higher pressure between them. So we convert, essentially, gravity on us, on all the surface mass, is essentially that gravity is being converted into atomic pressure. Atoms being forced closer than they want to be to each other. Which is really electrons closer than they want to be to each other, or protons closer to than they want to be to each other. That's the real force between atom and atom. Is always going to be, the real force is going to be created by electrons and protons, and the fact that they repel each other. I mean, protons repel protons, electrons repel electrons. Alright, so my theory says a real pressure force moves towards a gravitational source. So there's an actual field of energy, little bits, and they're going in all directions, and a certain number of them will always hit every piece of space in the universe in sort of an equal proportion, and the only thing that changes that equal proportion is when you put them next to each other and they start blocking, so to speak, absorbing the force, moving into each other because of that absorption. Alright. All real physics is nuclear. Matter does not interact with matter. Force does not interact with force. So those are that's one of my fundamental laws. Like a Newton law. That's a law. Matter doesn't hit matter. Electrons don't hit electrons. Protons don't hit protons. Neutrons don't hit neutrons. What happens is when they move close to each other, the little bits between them get pressurized, and those force bits force them apart. Alright, so that's enough of that. So, on to Daftlodays stupid no doubt video. Incredibly ignorant video. Preposterously unfounded, poorly evidenced, exaggeration, propaganda video. Literally. As they all are. Every single one of them lacks the single thing Daftloday should admit, which is the evidence for conventional conclusions is incredibly weak. And they should concede that the door is wide open to different foundational premises defining how the physical universe works.
So I thought I'd make a video with just a couple of notes, insights into the previous Leonard Susskind mechanics / Newton gravity refresher, and also draw attention to contrast with
Yes, I've already seen that video a couple of times. I mean, it's one of the few Susskind videos that isn't too heavy in math, but it also doesn't say much. It doesn't say anything really.
DraftScience. One of the first things Susskind reminds us, is F equals ma as a Newton law.
Yeah, so that's force, not frequency. So they've turned that into frequency now, ironically. And again, mass times acceleration from what? So this idea that something accelerates magically through some magical mechanism, and clearly, saying F equals ma when Susskind in the video basically converts that into Heisenberg times frequency equals, so they always convert into their own jargon.
Strangely, later he says something like we have mg minus mg, and this is a force law. Now, F equals ma is a principle that reigns supreme.
Well, I don't even know how it could reign supreme because it doesn't really even say anything, in my opinion. It's saying something about momentum, maybe. Um, but again, the force required to move a mass, to create acceleration, you could argue. So acceleration equals, um, the mass divided by a certain amount of force. Some other way to write the equation. But to just say F, which is some sort of ambiguous force, required to what? Move a mass a certain that has a certain acceleration. I mean, a certain mass with a certain acceleration will impose a certain force. Yeah, so you're just basically saying what I would be arguing is that as you move matter, you move the matter in a direction. You change its orientation in the 3 dimensions. The matter becomes heavier in the direction it's moving, and it becomes lighter in the directions it's not moving, quite obviously, quite intuitively. And that's really what that's saying, is that as you move something, you orient the force in the direction of the motion.
And when we study mechanics, we're interested in perhaps measuring and guessing at a force law, and then equating the two. And
so the force law here is, in the bent space world, is that whole thing called a force isn't really a force. That's bent space or something. F, there is no F. There's the bent space contracted the space between the objects, gave them an acceleration that could be sustained as a velocity depending on their circumstance. So for us, the acceleration doesn't become a velocity. We stop moving because the Earth stops us from moving. So we don't gain any velocity. We're just in perpetual acceleration. We're accelerating 10 meters per second, but we're not moving. We have no velocity, technically or untechnically. I would argue our atoms do have velocity. They are moving a speed, but the rebound speed cancels it out. So we do bounce on the surface of the Earth aggressively. The bits inside of us are bouncing in the gravity,
revealing and finding out solutions to the second order differential equation usually. Because he points out that acceleration is the second derivative of position with respect to time.
Well, obviously you have to measure acceleration or velocity based on covering a distance in a certain amount of time. So covering the distance and not counting how much time it took, you wouldn't be able to know how fast it was going. So it always has to be miles per hour or meters per second, or you can't measure velocity or acceleration any other way than to time how long it takes to move a distance. Duh.
But I've got the position of those twos the wrong way now. There's something subtle going on here.
I would argue there's nothing subtle. Well, I mean, it's all subtle, but I mean, it's not subtle like we can't think of it or understand it. And again, I would just argue that if I illustrate it by moving something faster and faster and faster, like go from this pen moving to a bullet moving to some other really light thing that you could move quite fast, you could understand that the impact, the power of this thing gets stronger and stronger and stronger as that velocity increases. And it's because the mass inside of this thing, most of it now has one dimensionality. Most of it's moving in one dimension. It's not, most of the mass has a vector in one dimension. They're all the vectors are pointing in the same direction. Few and fewer of the vectors are pointing in the other direction. And that's what changes the mass into a beam of force. Eventually, if you move the pen the speed of light, you've converted it into its mass worth of photons in a beam of light. This pen becomes a beam of light if I move it the speed of light. A very, very, very intense beam of light, because there's a lot of light inside of that pen.
That for a long while I couldn't see. I could sense it. I think I got a good sense of when something, some truth, some intuitive truth, which or motivation in mathematics or physics, is not being told. Yeah? They're selling you an assumption sometimes, either because they've not thought deeply about the assumption. Not that it's wrong.
Well, I think that's the truth all over this whole conversation. Again, gravity was always a nuclear force, yet I was never taught that. We're always taught about how it affects these masses and how it affects bodies, but never really told that if we cut my head off and we cut my arms off and we cut my legs off and we separate them all, the thing will fall exactly like it would if I was all attached in one piece. So I can break the planet Earth into little tiny atoms and just move them all out separate locations, and the whole thing will be affected by gravity exactly like the Earth would have been affected if it was a whole. No difference. Those are important subtleties that have been totally ignored in the teaching of the science. The little bits are moving. There's a real force acting on the little bits. They don't just, for no reason, because of some space disappeared notion. That's not what's making them, move. What's making them move is forces pushing them, hitting them, being absorbed by them.
They just want to teach you as quickly as possible, and maybe it never occurred to them. The spidey sense didn't tingle. And the best physicists, explainers like Feynman and Susskind, they had their own spidey senses, and all credit to them. They tried to impart the little things.
They don't impart shit. I mean, Feynman's explanation of magnetism is evasion all over the place. I can't explain it to you because you're too stupid. But the truth is, he doesn't have an answer. I have to invent a fake, phony thing and tell you the fake, phony thing does the magical bits. It does all the important stuff. So I can only explain stuff that doesn't have anything to do with magnetism, really. Because the part that actually makes it happen, that makes one thing move into another, I'm just going to tell you it's a virtual, made-up thing that I'm just going to say it's like, photons got shot out of it magically. So what a pile of shit.
That so often get missed. But when like me, you have learning difficulties and Asperger tendencies that drive you to want to understand it at a deeper level, which require deeper motivations to understand the motivations behind certain assumptions.
Yeah, so he thinks he's done some of this, because he's retarded. If you have special retardation powers, then you can pursue the real truth, because somehow you have now X-ray vision or something, your special Asperger vision. Bullshit.
Well, classes can find you very troublesome. I remember one electronics teacher when I was in college losing his temper with me and saying, "You're so goddamn unorthodox, nobody understands what you're on about or thinking." Because he was trying to explain how a DC motor worked.
Yeah, irony all over the place, because now he's sitting here defending the orthodoxy. I mean, what can you say? At one point in his life he could figure out that maybe they're talking shit, and now he's sitting here defending the pile of shit.
And they show this basic picture of, I think one of the methods of wiring a DC motor is called lap, and the other might be called lay, I don't know, I can't remember now. And they're just some pictures that you have to learn to draw for the exam, but I had no spatial awareness of how that fit with the theory of DC motors, how it's taught. in the general sense. That's when he lost his temper with me. And his answer was, "Oh, to explain that to you would be a 2-hour lecture on its own."
Yes, and it'd probably be worth it because those are sort of important things. But yeah, that's all the Maxwell crap is which way the wire's going will decide which way the field is going, which will decide whether it's going to put pressure on something or not.
And I don't have the time.
Field of particles.
Now, well, that's confirmation that yes, there is more to be understood, and there is a gap here, and I am asking you just to swallow something and learn to jump through the hoops. Anyway, I think lots of people actually have a problem with this method.
Yeah, well, you don't seem to have, like I say, you're completely defending the method. You've made irrationalized arguments about how they need to not tell the truth and how they need to create fake three bear stories to explain it, because if they explain the real Goldilocks story, nobody will go for it, so they have to put it into three bears metaphors.
Yeah, some people just understand from the get-go, you know, yes, I'm jumping through hoops because I want a good job and I'm happy to do it. And there are just some people who just can't stomach that. That's the motivation, that they're trapped in such a rat race game where, you know, they feed it, you eat it, you excrete it.
Yeah, you don't have to believe it though, so that again, that's more kind of bullshit. That yeah, I could learn a foreign language and I'm sure I would find some of the words idiotic and they sound funny and they're kind of gay. And you say, ew, that's gay. But yeah, you know, it's the language. You say, okay, I'll accept that, but I'm not going to live it. I'm not going to, you know, when I actually speak that language, I'm going to avoid that fucking word because it's gay as fuck.
You go on to have a successful life and career. Anyway, right, I'm getting distracted, but shared a little of myself there. Right, so this is the force law that we know, I guess, that a falling body experiences, or even a body at rest. But once you know these two equations, or this one equation and this other concept of the force law, you know it.
Yeah, this other concept of the force law besides the force law that's really simple and says when big F equals ma. There's another force law. It's all the same. Force is intimately associated with, first, the idea that if it was just the force, F would equal F. Like the exhaust from the space shuttle. That's just the force. If I just cut off that force, no matter where I put it in the universe, it's still force. But it can't do any work until I put it next to a piece of matter. Now it can push the matter, the force. So the force needs to act on a piece of matter. Maybe that should be one of the laws. Forces act on matter, not on each other.
Equipped with a little bit of calculus to analyze and devise more definitive equations for many situations. Yeah? Say the parabolic trajectory of throwing a ball.
Yes, but all of those are going to be the same exact thing, as the real forces are going to happen on the nuclear level. It's going to be electrons pushing into electrons and protons pushing into protons. And there won't be anything else that decides where that baseball goes than the fact that the force has to be transmitted to all of those little tiny bits. Each of the atoms inside this finger has to be moved by a force. It has to have a pressure created that forces it to move this way, and then forces it to move that way, and then forces it to move that way. And somehow my body, through expansions and contractions of cells, and then expansions and contractions of the energy level of the atoms in those cells, pressurizing the atoms and depressurizing the atoms in terms of creating energy around them, is creating that tension where this side becomes contracted and this side is expanded, and then the other way around, and my finger moves. Well, it's probably the muscles back here doing that.
Where you consider that the force is acting upon it, it's minus mg, and you can generate the parabolic equation for that. Or in the exams they make it a bit more complicated and say, you know, a cannon on a cliff perhaps shoots. So you kind of have that situation.
And again, it's better to use examples that get right to the nuclear bits instead of examples that are where you have to go through the mediums. So my finger's a medium. All the atoms are tied to each other, so it's hard to see the actual force changes that take place inside the mediums. But like waves in an ocean, the force is pushed through the medium.
Then they work out. You do a kind of maximizing and imagine a tank, yeah, and yes, it has lots of individual trajectories, but you can calculate an extra parabola, which is.
Yes, you can calculate. That's right. You could, it's like the old video game with the gorilla throwing the bananas. Yes, you can calculate trajectories and compensate for the wind.
It had a fancy name which I was just forgotten
Angry
now,
Birds.
but it's the parabola of basically the maximum range. Yeah, and it turns out that there's always two routes. You understand? You could have, and it's solving an equation. When you shoot at an object, you can shoot it. You could shoot it there and it fall here, but you could have shot it up and down. And you can analyse this motion. And there are other scenarios that this sets up for you. Bodies.
Yeah, there's two forces in those equations, right? I mean, there's the force of the cannonball getting accelerated by the gunpowder, and then there's the force of the gravity and how you're interacting with it, directly or indirectly, full on or incrementally.
Wheels. And weights, where you've got tension in the string, which is a force law. You've got the force law of minus G. Then there are spring laws, which I think just follow a constant. It's just some K times the mass, perhaps. Maybe there's a plus C, but it's kind of got a linear form.
Yeah, so does the friction element, is just like the K element. And like the tension in the string even has its own elasticity element. So there's constants for all of those things based on what the surfaces are made out of. So
same with elastics.
Those are dampening effects. Those are things that consume force. They don't transmit force.
Elastic springs. And the details of all these constitute the force laws, which you can imagine building a meter, and it points to different numbers, and you can have a guess.
So again, I would argue that all of those things don't define the force laws. The force laws are always nuclear. They're always happening to the little bits. Those are the laws. The bigger bits can express those laws, but the more complex, the more elements of drag and tension and changes in mediums, changes in molecular bonding, the more of those variables you throw into the mix, the more complicated following the nuclear path becomes.
And intuit the force law, and once you've got the force law, so mass times constant, it is, I'm pretty sure. So in the case of a spring, you equate a mass times a constant to as it was put, the second derivative with respect to time, or distance with respect to time. And the two m's will cancel.
Let's understand that those constants, spring constants, are a lot less reliable than the constants like big G or something. So the spring constant isn't a constant like the speed of light. It's a general principle that applies, but nothing's rigidly held to these constants. So they're just the closest approximation we can make, but that's all it is. It's not a true constant.
And you have a question now: what kind of functions would give rise to such an answer? And this is where you get the exponentials coming in as an answer. Sometimes, I forget how it pans out, but sometimes there are two exponential equations. But even considering one, if usually that can be a special situation. I forgot what that one is. But as soon as you invoke the exponentials, you then realise that the sine function, because of Euler's,
It hasn't gotten anywhere near how this has something to do with orthodoxy versus draft. So again, we're 12 minutes into the video. There's just no clue how this has something to do with my theory or proving it right or wrong.
identity, which is cos theta plus I sine theta, something like that. And this is kind of how you I made a video, this was by Lewin, capturing a video, a really good video, where he shows what he calls simple harmonic motion as being equivalent to some, he shines a light on a weight bouncing, while simultaneously shining a light on something rotating, and you can see that they exhibit the same shadow function. Yeah, and in this sense, simple harmonic motion is circular motion.
So in the sense of a completely made up, even though the motions themselves are not in any way the same. I mean, they're the same, and then the diameter is the same. So the fact that you can fool yourself by holding a circle this way and think it's a straight line or something, it doesn't. The fact that those little tricks of similarity exist doesn't make a circle into a line.
So
just as an on-off pattern doesn't mean interference.
there's that. What else do I want to say before I move on? Okay, but all this notion of forces, everything in the Newton schema, and the classical schema, talks about a force, and it talks about forces in the context of an abstract idea of bodies that have the abstract idea of a number called mass.
It's not an abstract idea. So again, this idea that somehow mass is an abstraction or some distortion of its reality, when it's the most reliable thing you could possibly have, is this identification of atomic weight, of the fact that there's a certain number of electrons and protons, and based on that number you'll absorb a certain amount of energy to move a certain amount of distance in a certain amount of time, and it'll take more energy to move the big thing than the small thing. And that gravity clearly has the energy to provide. It can give you a little tiny bit if you're a feather, and if you're a cannonball it can give you a lot. It gives you as much force as you need to move 10 meters per second per second.
When we say Fm equals ma, this is in a sense a definition. It's a motivated definition, and actually Richard Feynman, this is...
Look, if you want to argue my theory, I mean, I've sort of pointed out quite clearly that I think the force bits are the origin of the mass. And so the mass number is just an equivalency to a force bit. It's telling you how many force bits are inside of the thing. So if the thing has mass, it means it contains, let's say, 1 million photons per ounce, or per gram, or per... Let's find something smaller, and we'll just give it an arbitrary number for the sake of example. But yes, that would equal a certain amount of force. A certain amount of photons is what that can be converted into. That's what gives the electron its three-dimensionality, is that it possesses a certain number of photon volts, we could call them. Okay, a certain number of photons moving in individual vectors. And that's its mass. Its mass is an actual captured force, and each force bit, we could just say, has the force of one Gary. There's one Gary, okay, in a photon, and an electron has a billion or a million Garys, and a proton has a billion Garys, and the atom itself can have, a trillion Garys. You get it?
Does a good work through about explaining why it couldn't be, as Aristotle proposed, m equals mv, where
again, let's understand, velocity is just a consequence of acceleration not being inhibited. So if my acceleration is not inhibited by the ground, then I will acquire velocity. I'll just keep adding to my velocity as I'm perpetually accelerated. But an acceleration of a certain meters per second is exactly the same as a velocity of a certain meters per second if it's not interrupted.
Equals ma implies a body in motion remains in motion unless something happens, and F equals mv implies a body is in motion as long as you're pushing it, but when you stop pushing it, it stops.
I don't see how that's true at all, but as I have pointed out, velocity is capturing. So acceleration, you could argue, you can be accelerated and then you lose the acceleration. Like when we hit the ground, when we're pushed into the ground, our acceleration goes through us and then it goes into the ground as pressure on those atoms. So our acceleration doesn't stay. And you could argue that that's happening with the Earth going around the sun. It's accelerating constantly towards the sun, but that acceleration doesn't turn into a velocity towards the sun because the Earth is moving in a new vector, and its velocity going this way consumes the acceleration and turns it into a change in its direction. And so the acceleration is used up, changing the direction.
Both negating friction. Only in the case of an additional force, one of them potentially being friction, under the F equals ma schema, do you have bodies stopping. Now then.
So if he really wanted to contrast my theory to their theory, again, this is another point where I've sort of made it clear that force is absorbed. That's acceleration. Force that's held is velocity. So a photon perpetually moves, is my argument. It never stops. When it goes inside of an atom, it's still inside the atom, or exchanges with some other photon. I'm just saying the idea of its vector in a direction, okay, can go in, and that element of force is exchanged between the other elements of the atom, but it always remains in a direction. Now, this direction is retained until it gives this direction up. So when the space shuttle takes off, a bunch of energy going this way, the direction of the motion of the shuttle, is absorbed. And it's absorbed in such a way that now it's part of the structure of the atoms, so it stays in there. And so the atoms all have a bias in this direction. And that's why the space shuttle keeps moving unless it hits a force that stops it, because it's holding the force. It's exchanged stuff going this way and that way for stuff going this way. And so it's made of stuff going this way. The little bits, the photons, the little bits inside the electrons and inside the protons have a bias in a direction. Most of them are going one way. Not most. An imbalance of them. A likely very small percentage of the trillions. So a billion of the trillions is 1 billion more is going this way than that way of the trillions going this way and that way. And that bias means it'll keep going. So it's kind of stealing the perpetual motion of the photon. And it's stealing it in a rational proportion where the space shuttle is only going 20 miles an hour, or even say 10,000 miles an hour. The photons were going the speed of light that it absorbed. So it's converted the speed of light into 10,000 miles an hour, which is the dilution of the percentage of the number of photons going in this new imbalanced way versus ones going in the opposite direction. So it's just changed the balance. 1% more going this way than going that way equals 10,000 miles an hour. That kind of thing. But the matter is holding things that have perpetual motion. And if it's holding an imbalance, that is more fish going one way than the other way, then the school of fish goes that way. Argue that. Contrast that to their theory of motion, which is it just moves. Once it moves, it just keeps moving because of the keep moving theory. No explanation for how it keeps moving, how the material things keep moving, and no explanation how they don't do it consistently. That is, the electrons don't keep moving. You know, can't make an electron gun in the true sense of the word. Can't make a gun that can shoot electrons across my driveway and hit my neighbor's house, because the electrons run out of gas. They somehow can't capture the photons permanently. They can only interact with them temporarily. They can only be accelerated. They can't hold the velocity.
But even though we have quantum mechanics developing, at one point Leonard Susskind tells us that in a very real sense the mathematics of quantum theory is still dealing with what we call a simple harmonic oscillator.
Yes, well, whatever. He says a lot of things. Hologram, string theory, many world. He says lots of things. All wacky.
Or motion, simple harmonic motion. Yeah? And I guess, reading in between the lines here, what he's telling us is an answer to the one of the potential questions of what a field is. And a field is perhaps a further idea that each point in space isn't actually just a number that can be varying, but it's a simple harmonic oscillator.
Right, okay, so let's make the reality so many levels of complex. So it's not a checkerboard with checkers, it's a checkerboard with springs. So the underlying foundational function is much more complicated than what we see in the big universe or in clouds or in mountains or in grass or in anything. They have all these springs that are loaded, and they're loaded by some matrix math, and that's deciding how things move through the universe. So instead of the simple explanation, which is there's a bunch of energy in the universe creating pressure, and that's why planets are spherical, and that explains everything about what's happening mechanically, is that force is interacting with matter by strict rules of the force has an energy of 1, and it interacts with things, matter bits, that have an energy of 1 billion, and it interacts them by certain rules.
And a connection of such things which can wibble wobble and transmit wibble wobbles through points in space, still obeying F equals ma. Yeah? We still hold to F equals ma in the notion of bodies.
Yeah, except everything's doing some kind of jiggling from nowhere. So again, instead of blaming a real force that sometimes throws one more head and one more tail from the other direction, that the odds of probability means that it's going to push a little more this way 1 second, the next second it'll push a little more this way, and the next second it'll push a little more this way. Instead of explaining it with some kind of rational theory, we'll create an invisible force thing full of little springs that are constantly getting compressed and expanding, by some mechanism where somehow they're able to transmit that expansion and contraction coherently, which I don't even think they could make a model of.
In quantum mechanics, I believe. Contrast this with DraftScience. DraftScience may or may not, I'm not sure, believe in F equals ma. But one thing's for sure.
Well, again, it depends on how you want to describe it. Like I said, you're basically saying force equals force accelerated, which would, in my opinion, be force equals force bias. So the more you bias the force in something, the more force there is. M is how much force there is, and A is just telling you what's the bias. What extra bias are you imposing on the mass? So the mass can already have an acceleration in one direction. You apply an A in another direction, you're just creating another bias. So yeah, I believe in that.
Is when you most often hear him talk about force, 50% of the time it is in the common notion of forces on bodies, but he won't be specific enough.
So I don't know how specific I can get. I can tell you that all the forces are one thing. They're these little tons. They can be in the form of gravity, which is the tons without any frequency, and mixed polarization. And polarization is something simple, square versus round, two kinds of polarization, that's it. So the force bits can be unpolarized and have no frequency between them, no coherent frequencies. Or the force bits can be at a consistent frequency and of one polarization, that is square, all squares, let's say, and that will be called a photon because it's all electron force. So they're all square. Let's say the electron is square and the proton is round, and those are the two polarizations relevant. And I've explained the polarization part, so I don't want to do that verbally. It's better to do that with a drawing or go to the website and look at the drawings of how that polarization works and creates magnetism. But yes, all these forces are real little bits. They're accounted for. There's no virtual photons, there's real tons. And they're real force bits. That's what they're called now, force bits. They all have an energy of 1. They all have a mass of 1. They're everything that makes the universe do something. The universe doesn't do anything unless the force bits force it to.
To clearly identify whether he's standing on this notion of a force, and then the other 50% of the time, force becomes...
Complete lie. There's no inconsistency in my description of force and matter. So it's just a complete lie. I mean, I've made over 600 videos. There's no inconsistency. I've never even changed the basic force laws. So that's just rubbish. Another, like I said, another one of these comments he just throws out, like somehow I've said inconsistent things on the subject when I haven't been anywhere near an inconsistent point about what's a force and what's matter, and why matter holds force and why force is free, and the fact that free force doesn't interact with free force, and that the two are a catalyst for each other's function. Force can't have a relevant meaning in the universe until it hits a matter bit. And likewise, matter bits can't do anything in the universe until a force bit forces them to.
A second force has a second meaning, which is context related, because what he means is a fundamental particle.
I always mean a fundamental particle. There's no other force. I've never described any other force. A fundamental particle makes every piece of matter that moves move. If a fundamental force doesn't hit it, a fundamental force bit doesn't hit it, it doesn't do anything. It doesn't change its behavior. As stated, matter can have a bias already in it, in the sense that it has more force bits going one way than it has going the other. But if you put them all in a neutral state and shove them into the universe and don't create any force to interact with the matter bits won't move. You have to create the field energy to have interaction.
He has the idea, without explaining it specifically enough, that a body captures a fundamental particle.
I have explained it. So again, I mean, I went through it over and over and over again. So I mean, it's just another grotesque fucking lie. The guy's just such a compulsive fucking liar. So I did explain that there's this idea of a right turn because of the polarization. I won't describe the exact functions of that, but I described the fact that matter becomes a trap. Okay, so the arrangements between the protons and the electrons creates a positive and negative field dichotomy, all right, where the electrons the energy will move perpendicular to its interaction with each other. So black force on black would just create reflections. Black force on red creates a perpendicular release of the energy. So I've pointed that out. I've drawn the pictures of the 4 right turns that equal a circle. A circle that can be a perpetual trap that the energy is caught in. And that the simple dynamic would be as you put some electrons or protons on one side of that circle, if you weight that circle unevenly, then you'll have more mass going one direction, then you'll have mass going the other direction, And that way that circle will, just like Mercury, it will process in space. It will move in a direction because of the procession of that imbalance in how much mass is being moved. So I have explained it. It's just a lie to say I haven't provided an explanation. That's the trap matter creates for energy. That's why nuclear bombs explode and all the rest of the shit that happens, because energy is trapped in atoms. Fucking asshole.
And experiences force. Now, this whole concept has not been thrashed out clearly as to demonstrate whether these classical Newtonian principles have been abandoned.
Yes, so how are they abandoned? You know, I'm just saying there's no, what's so complicated here? I mean, where did I abandon the idea that the force has to come in? The shuttle rocket has to actually change the force dynamic. The force has to go into the matter. The matter reorients in terms of the atoms collect the force, they trap it, and there's a bias in terms of direction. There's no absence of conservation. The little force bits have to go into the shuttle for the shuttle to gain the velocity.
Or whether these things are something new and haven't been clarified enough to give a mathematical interpretation to what this is about. You see? Because general...
well, again, it does. I'm just saying, again, me redoing certain math would be idiotic because the math is perfectly good. It just has to do with identifying the percentages. And so we sort of know how much energy it takes to move a certain amount of how many calories it takes to move a certain amount of, or how much horsepower, or all the other things they have to define energy amounts, how much it takes to move a certain amount of mass, a certain amount of distance, in a certain amount of time. So that's already tested physics. We already know what those answers are, and I'm just saying that clearly I'm saying that's the proportions. Yes, when force goes in, a certain amount of it gets trapped, a certain amount of it's released as waste energy because it isn't trapped as heat and other things that happens with just common atomic structure. But if we cool the materials and we do other things, then we can create superconductors and other things because we eliminate all the waste. And so we have a very efficient system where all the energy goes into being stored. Again, I don't have to do math to have an alternative explanation for the source. We're talking about the source. You're saying bent space is math. Bent space isn't math. The inverse square law is the math. Okay, the inverse square law dictates the math. There's no bent space in the math.
Forces lead to accelerations and velocities.
Again, there's no Huygens in the math. There's no Heisenberg in the math.
When the force is removed, it ends up at a constant velocity. And you can understand that something like a bike wheel, as I've explained before, at a constant velocity of 30 miles per hour, whilst actually stationary in contact with the ground.
Stationary going 30 miles an hour, so right there you're in trouble, but whatever, go ahead.
Must have every piece of it averaging between 60 mile an hour and 0.
Yes, every piece of it is constantly in motion and changing those vectors, just like every piece of us is being constantly changed in terms of our vector. We're spinning around a round Earth, so we're moving in very strange patterns, and the round Earth is going around a round sun in another round circle with another bunch of changes. With every zillionth of a second, every Planck constant of time, there's a new arrangement caused by the combination of a new amount of force hitting us, and force hitting us from a different direction. So yes, the wheel, the atoms in the wheel are constantly reorienting themselves to their obligations based on their new position. So wherever their position is will dictate what forces are acting on them. Fuck.
Now, this is in classical analysis, and the question which is posed is, in what sense does adding a particle of force, a particle, contribute to the increased average?
It's pressure. The pressure goes in and let's say the pressure hits an electron. The electron moves closer to another electron. That electron moves closer to its neighbor. That neighbor moves closer to its neighbor. It creates an increase in pressure in the system, and the system fights back by saying, eventually I have to release that extra pressure. I push the trampoline in, it pushes back. There's nuclear physics involved in that whole adventure. Me pushing, I don't get to push on the actual matter. I'm pushing on the force between the electrons. So I'm compressing the force between the electrons. That compression of force means it goes into the material, and it forces the other atoms to move away. You know, fuck. Not complicated. That's how it happens. Matter rejects force.
Of the speed. You can't talk, as in Mendham does, as, well, you have more arrows going that way than more arrows going that way. Because that leads, that notion quite readily leads to the notion that anything moving is basically splitting apart and losing all consistency as a...
Yeah, it's not losing all consistency, but it changes how it vibrates. So the pressure is on all of the atoms. They're all tied together. So yeah, they don't go flying in new directions. It's all dampened through trillions of pieces of string. So I have trillions of pieces of string holding things together, and I poke one of the things. Yes, all the strings will dampen the effect of that movement, and it'll turn it into a general movement. Shit.
Body. Because some of them are going that way and they'll leave, and all the ones that go in this way, well, they go that way.
Yeah, that's right. You know, there's a gazillion things happening in 1 second of time. 1 second of time for a photon is like 1 billion years for us in terms of the activity that's taking place. Millions and trillions of little events take place on that fucking subatomic scale in 1 second of time. It's an incredibly deep pool of checkers. There's billions of moves taking place on all these little tiny squares. The board has so many fucking squares, and you can't figure that out. But that there's general patterns created, and the general patterns move a lot slower than the little individual checkers moved. So the little individual checkers play the whole game of checkers, and now all the blacks are on one side and all the reds are on the other side. And we can see that pattern move because that one moves a lot slower than the whole game that took place to create that pattern. You know, so you can't figure out that the real universe isn't on our slow time scale. It's not on this material time scale. It's on an atomic time scale where the speed of light isn't all that fast. To electrons, the speed of light isn't anything, whoa, look how fast that's going. No, it's no news at all.
DraftScience hasn't really solved the notion of the need for an average velocity amongst particles.
Again, the average is that some are going, at this very time I'm going 50 miles an hour in a direction, there's fish. There's pieces of me going 50 miles an hour the wrong way. There's pieces doing that. But the average is that there's a lot more pieces going this way than that way. Yes, there's an average, and the average contains a lot of stuff not going anywhere near the right direction. That's why I'm only going 50 miles an hour. If all the stuff was going the right way, then I'd be going the speed of light. 50 miles an hour is so much slower than the speed of light, then you can sort of understand that it only requires 0.000, let's say 10 to the minus 15 amount of imbalance inside of me for me to go 50 miles an hour. Only a tiny, tiny, tiny fraction of my total mass needs to be imbalanced in that direction for me to go 50 miles an hour, because it's incredibly slow relative to a complete imbalance, which would mean the speed of light. So I'm really far from a complete imbalance when I'm going 50 miles an hour. Really far.
And how adding one particle changes the average velocity in a body. And
so again, adding one particle. So again, he's saying that somewhere I'm theorizing that one photon can move a 10,000 pound weight. But the truth is it can. It's just going to move it so fucking little. It's a tiny amount of velocity in balance. So yes, it might take 10,000 years for the 10,000 pound weight. I could hit it with a photon, and it might take it 10,000 years for that energy to move all the way through that 10,000 pound weight and move it the distance of an electron to the left. But it would do it. It is real energy. Every little thing, every little bit is a real piece of energy with a value of 1. And if there's an imbalance, there's 2 on this side and there's 1 on this side, that imbalance over time will create motion.
This was illustrated by a great question by somebody asking how Newton's cradles worked, which totally illustrates the fact that Inmendum does not have notions of bodies. Because the question becomes, how, when this end sphere impacts the rest of the spheres, does it cause the...
So he's drawing behind his own image. Very helpful, thank you. So when one sphere interacts, I thought Newton's cradles had something to do with spinning buckets, but whatever. I'll have to find out what the hell you're talking about. But you think this is a real argument? Somehow Newton proved that particle theory couldn't work? I don't think so. I don't think so.
The end one to swing off. Now we can understand this.
Oh, okay, so it's the kinetic ball argument. Yeah, well, the point is because it's a transfer of electrical energy. When they're touching each other, idiot, are very close to doing that, the force transmits through them without creating any acceleration. And because they have another mass on the other side, okay, that's also prohibiting them from moving without creating more pressure. So it's always an equalization of pressure. So the pressure travels through the atoms as a wave, as a I'm a piece of matter, you're a piece of matter. Now if the atoms are close enough to each other, then the only thing they'll hit is the force. This one will move a little towards it. That means the force is compressed. That means there's more pressure. That means this one moves. And then this one moves, and this one moves. And that's what's happening. The force is moving through them like electricity moves through. And then the last one, who's free, who doesn't have any external pressure in its way, has much lower pressure because there's nothing right next to it. That's the one that leaves because there's no pressure. It doesn't have to move more matter. So that's the matter that just keeps going because it never hits anything. The pressure never increases. It's like me free falling. I free fall if there's no earth, okay, for which there's a pressure problem. And so when there's a pressure problem, how come you could ask the same question, dummy, asshole, bullshit question? Well, why don't I create a big dent in the earth? Well, because the pressure moves through me and through the earth, because we're connected to each other. And the forces and the tension just move as a pressure wave. They don't have to move by actually moving atoms beyond just vibrating them. The pressure can be transmitted through the vibration. Because they're all connected by tension. If you raise me 5 feet off the ground and then let me go, then I'll create a dent in the earth. If you take the steel balls and separate them by enough distance, then you'll break the continuity of the last ball flying off. Yeah, it won't do it as well. It'll still, the last ball will go more distance because the last one doesn't have any pressure. There's nobody to bang into. There's nobody it has to exchange completely its force with. Steel balls are not elastic. They're not inelastic. They won't bend. So when something hits them, it's a complete exchange of force. Jesus. He hasn't explained it. He hasn't said anything. No, I have said. You fucking lying piece of shit.
One model in terms of conservation of forces and momentums, because we have the notion of bodies, and our notion of bodies is built upon quantum mechanics and the notion of
they're not bodies, they're waves. So again, he says we have a notion of bodies when the whole of quantum mechanics is wave theory, for fuck's sake. There's no bodies in quantum mechanics. There's nothing actually banging into each other. They're all banging into each other based on some perturbation in a field, how much they affected the field. And my argument is the same argument, that this thing will never hit something else. It has a field around it, and that field will interact with the other things. There's no matter bit hitting matter bit. It's the forces around the matter bits are what's hitting each other. Dumbass.
Electric charges, which are accounted for in quantum mechanics, that give us
So he says the electric charges are accounted for. There's no accounting for the energy. They're called virtual photons. How is it accounted for? You just have a whole bunch of energy that shows up from nowhere. A bunch of energy where these particles all of a sudden are creating force fields around themselves. You don't explain, where does the force field come from? Where does the magnetism come from? What is the source of that force? Those virtual tons that are doing all of this, making shit happen, where do they come from? You have no explanation. You just say they come from the invisible ether.
And structure of bonds and an outward electric force.
Yeah, and I've explained all the bond crap with a simple argument about polarization. All the bonds are essentially magnetic. Electric charge is a magnetic phenomenon. The electron and the proton are in fact the magnetic monopoles, quite obviously. Where's your counter argument? How do you explain how an electron is not a magnetic monopole, or how a proton is not a magnetic monopole?
Provides this apparent solidity of contact of bodies. And there's a thing for you.
So again, I said the word tension 5 million times, that all the atoms are under tension. The pressure between them is a real force that's between them. You compress the force, it becomes a more powerful force. I've been over this. There is no thing hitting thing. The force hits electrons. Electrons don't hit electrons, generally speaking. I mean, maybe in special circumstances they do, but essentially it'd be the same as force hitting force, because they're force.
Emendum. Light is often shown as two waves like this. An electromagnetic wave and a magnetic.
Yes, right. Some sort of interference, some kind of perturbation, some sort of warpy thing, okay, that doesn't spread, that somehow moves through some sort of medium in two ways at the same time. It goes fat this way and goes fat this way, and then it goes to zero, and then it goes fat and fat. Some kind of weird, bizarre, totally unexplained bullshit that isn't correlatable to a single fucking thing in the universe. It doesn't have a single parallel anywhere in the known universe. A completely made up concept, not even close to a fish, not even metaphorical to anything known in the universe, completely godlike in its completely made up nature. It's not even 3 bears. It's 3 aliens. It's 3 Haggadabuzgas. It doesn't have any correlation to anything real whatsoever.
Wave 90 degrees perpendicular. But the truth is, the magnetic force is supremely weaker. And this is still not to scale, because I believe it's
as if that would matter. There is no magnetic force and no electrical force. Again, the electricity is completely not a real force. There is no electrical force. There's no such thing. Electricity is a byproduct. It's the movement of electrons is electricity. Photons don't move electrons. Photons moving through the ether don't move electrons. Photons have to hit electrons to move electrons. You silly fucks.
Time less. But what really should be done is this, perhaps. And this is because there are 2 phenomena in the world. Electrostatic force, which can be seen if you rub a nylon rod and deflect water from a...
Yes, that's all that is polarization. You're creating basically a kind of magnetism, and that's all it is. There's no electric force that's any different than magnetism?
From a tap, yeah? Or rub a balloon and stick it to the wall.
And it's clearly because the water goes negative. It creates negative ions. The negative ions become the north side of the magnet. The positive ions are the positive side of a magnet, the poles. That's why it deflects the water. It's magnetism.
Or you make an oscilloscope, cathode ray tube, which works with electrostatic deflection plates, yeah? That gives you your electronic.
And those deflection plates are just taking the place of what traditionally on a TV are the giant coils of wire that are put around the television to deflect the electron. It's again just creating a magnetic field to move the electron.
Device monitoring machine. Contrast this with the force of magnetism, which in essence is really weak, but can be...
I would argue an insane statement on its face. It's not a really weak force. It moves matter, and it does it without any source of energy, as you people don't account for. Magnets move things without any energy having to be put into the equation at all. You don't have any explanation for that. I do.
Additive to be as significant as the electric force and beyond, say in the traditional TV set, which uses coils of wire instead of electrostatic plates to control an electron beam.
Yes, exactly the same. Like I said, there's absolutely no difference. Electrons are magnetic monopoles.
But both items are using fundamentally different forces. We say because we have this.
Claims you that they're different forces. So give me some experiment that illustrates how the force is somehow different. How this doesn't simply have to do with how the electrons and protons are positioned. We already know that that's what makes a magnet work. Is the electrons are on one side, the protons are on the other side, and this is filtering the virtual force. Okay, I'd say the real force, but yes, and it filters it in this particular way with the rays coming out of one end affect electrons, and the rays coming out of the other end affect protons. It's all magnetism. The electricity part is just the fact that the electrons are moved by the force. The magnetic force moves them.
Theory that connects the two. We say our theory is electromagnetic and is a unification theory of the two because we understand a relation between the two. But in the world...
Yes, we understand a relation between the two things that you write separate waves for and pretend they're separate things. And even Feynman conceded this argument that it's one force. I mean, I can get quotes from Feynman basically saying that. It's one force.
They're actually two different exhibitable forces, which in Mendham, along with the weak nuclear force and the strong nuclear force and the van der Waals force and the
yeah, you can have strong magnetism and you can have weak magnetism. A fact. Something can be just terribly slightly magnetic and something can be very magnetic. And especially surface charges create a kind of magnetism because all the electrons are lined up on the surface and there's protons behind them. So just the surface matter is magnetized, and that's the nature of charge. And it's just affecting the electrons, and that's why the electrons will move across the gap because the magnetism is very strong on the surface but very weak throughout the whole substance. So it has strong magnetism on the surface but very weak magnetism in terms of the entire filter. It doesn't filter, it's just the surface. You can't understand how weak and strong could have very different effects. How much you dilute the filter, how effective the filter is will decide how powerful the force emanating is.
Got his name for a minute, the plate force, and a million other forces. In Mendham decides he doesn't need to concern himself with them.
So another lie. I'm perfectly willing to explain every one of them, as just a dilution, as I just pointed out, a different kind of force in the sense that it's only on the surface, or it's in a material that isn't like steel. It's not capable of the atoms arranging as consistently, so it's weaker. It can't hold the magnetism because there's too much movement or spin inside the atoms. There's too much vibration in the atoms. They're not under enough tension metabolically, so they move around too much to maintain their polarization. Yeah, lots of explanations, asswipe.
These phenomena. Well, again, I can't believe I forgot it. Little add-on. It was one of the central purposes of the video, is to explain to you that F equals ma is kind of a definition. And like in mathematics, so often in physics, definitions are motivated by insights. Richard Feynman tried...
I'm not saying this isn't a good equation. I'm just saying all of this hype about something very simple, that accelerated mass means that the mass changes, that its dynamic is different, that now has a front end, and the front end will be able to impact things more than its back end because it's moving. Surprise, surprise. The piano, when it's held by a rope, can't hurt me because it can't accelerate. One end doesn't move faster than the other end. It's not going up faster than it's going down. So I'm okay. But once it starts going faster down than faster up, then I'm going to be smashed by more matter. When I interact with it, I won't be able to just touch it because it's going both ways. It won't be going both ways anymore. It'll be going more one way than it's going the other way, which means I'm in big fucking trouble.
Has to give you in one of his lectures a motivation into F equals ma by demonstrating to you that it can't be F equals V, mv. Right? What he's saying is it can't be. We choose.
I think it would be just idiotic not to recognize that when a bullet is fired and it has a velocity of 10,000 miles an hour, that F equals Vm. That the velocity times the mass is going to be the force of the bullet when it hits you. The bullet isn't accelerating once it leaves the gun. It's got now a velocity. So I don't understand how you're saying it's not the same equation. It's how you're thinking about it. You're breaking it because of how you're changing the circumstance and saying, well, the velocity I'm allowing to be degraded, but I'm not allowing acceleration to be degraded. But as pointed out, our acceleration is degraded. We never get to turn it into a velocity. So it's moot as force. We don't get to see the expression of our force because it's converted into pressure put on the ground.
Use it to be the second derivative of position with respect to time. What if, like Aristotle, we chose it just to be the first derivative with respect to time? And he says, as I've explained, this means you keep pushing something, and when you stop pushing it, it stops.
Which is the case for the electron, which is the case for the proton, which is the case for not probably the neutron. The neutron might be capable of moving on its own. I'm not sure. But the electron isn't. You can't give an electron perpetual motion. You can't flick one into the space and the electron just keeps going and going and going. It can't hold the force.
And to keep pushing something. This is fundamentally conservative, whereas this is fundamentally not conservative. And he does a good job, but the point is to realise this is true by definition. What you mean by a force, that to say a body has a force on it is equivalently to say the body is accelerating.
Right. So while it's being accelerated, it has acceleration. Duh. So why is velocity suspect in terms of force? Again, I don't know. How does the bullet not have force? After it's been accelerated, how does it not have force? How does the space shuttle moving through space not have force? Of course it has force. If I stand by the tail, I don't feel a thing. If I stand in front of its nose, yeah, I feel it smash me.
Or in the case of a static situation, the body, to have a force on it, to be stationary, must have an equal and opposite force, and in the case of removing that force, it will, as predicted, accelerate. Or in the case of seeing the body accelerate.
Yes, perfectly consistent with my theory, by the way. As soon as there's an imbalance in the force, the matter will do what the force dictates, which it will go in the direction of the imbalance.
Is the same as saying that body is experiencing a force. This is what it means in orthodox science for there to be a force.
Says you. I don't think orthodox theory. I don't think there's anything in orthodox theory that says bullets don't have force because they're not being accelerated. I think that's complete shit.
Uses the word force, but he should pick some other bloody word because it just conveys no meaning.
Oh, fuck you. I convey as much meaning as you can possibly convey. I'm saying a photon has a force of 1. That is, well, 1 ton. It's 1 photon by our measurement. That is measuring the whole frequency, which is 2 tons. So that would be 1 plus 1 is 2. So a photon would have a force of 2 then. The smallest photon, the smallest amount of magnitude of photon that we could measure as having a frequency. But I've been as clear as fucking you can be in terms of establishing what a force is actually made of. You're the ones who don't have an explanation. Where is your force that drives the Earth into the sun? Where is your force that drives 2 magnets together? Where is your force that forces electrons and protons to maintain their tension? Where the fuck is your force? You don't have an explanation at all. And yet you point your scurvy, bent, crookedy fingers at other people and pretend they haven't said it directly and explicitly. God, you're such a lying sack of fucking ugly shit.
In the face of, what he really means is a particle travelling in a straight line. So he's just said that. Because
Yes, that's what photons and all the force does. All forces travel in the speed of light in a straight fucking line until they hit a fucking electron, a fucking proton, or a fucking neutron. That's how it works. S for brain.
It's not explained, as I've said, how absorption of one particle going in one direction changes an aggregate average speed.
Yes, I have explained it. Capture in the migration through the electric and magnetic force of moving the electrons and the protons inside the nuclear bits. As the force creates more pressure between them, it migrates through every single bit of the structure. Every single bit. Every single bit. Because the thing is in tension and it always seeks balance. If I took 1,000,000 little magnets, put them all heads up between 2 plates of glass and forced them into tension, tied a string around it and tightened the string, all the magnets will be in tension, and if I poke one of the magnets, every other magnet's going to feel the poke. You dumb fuck. Okay, enough of that. So that was just... So another totally exaggerated video, like he did an actual pointed out some sort of real distinctions between orthodox theory and my theory, where he apparently implied somehow that I don't believe that mass can collect force through acceleration. Clearly, which we don't do. We don't collect the force. The force of gravity goes right through us and right out our ass. Just right through us. Don't get to keep it but for a mere millisecond, and then it's gone. And then we have to wait for a new hunk of gravity to do the same. But we never gain any velocity.